Okay, in this one we got a rectangle where the diagonal makes a 30-degree angle with a base. So I drew that in there in purple. So find the height of the rectangle. Sorry, if the height of the rectangle is 9, then find its area. So we have to find the base, which I did in orange. Now the reason why that was 9 root 3 is because this is a 30, 60, 90 triangle. Alright, we know that this angle is 90 here because it's a rectangle, and we know that this angle is 30 because it's given. So the side across from 30 is 9. So the side across from 60 has to be root 3 times that side length. So when you do 9 times 9 root 3, you get 81 root 3 square units. Okay, in this problem we got to find the area of a square whose perimeter is 16/5. So what I did here is I multiplied it by 1/4 because all the sides are equal, so all 4 sides are equal. So when you divide 16/5 by 4, that becomes 16/20, which reduces to 4/5. So each side length is 4/5. So to find the area of a square, we square the side lengths. When we square a fraction, we square the numerator and the denominator. And our area comes out to be 16/25 square units. Now you might be thinking, and if you are, that's good. Just in general, if you're thinking, that's always good. But you might be thinking that why is the perimeter bigger than the area? And like I said, it's good thought, but these are actually different units. So like the perimeter is just in units, the area is in square units. So you don't want to compare it like that. It'd be like comparing like your speed to your weight, or like your height to your circumference. I don't know. But they're different things. They're different units. So that's why you don't really want to say, oh, the perimeter's bigger than the area. They're different things. You wouldn't say, oh, I am faster than your height. Like, that just wouldn't make sense. Alright, so the area is 16/25 square units. Okay, so in this one we're given a rectangle that has a diagonal that makes a 35-degree angle with the base, and the base is 10. So if you draw the diagonal, it creates a right triangle because rectangles are equal angular. So you can use SOHCAHTOA here to find the height. So we use tangent because if we look at 35, the opposite leg is h and the adjacent leg is 10. So the tangent of 35 is equal to h over 10. Then we could cross multiply and we get h is equal to the tangent of 35 times 10, which is 7. So the area is just going to be 70 square units because it's just base times height, 7 times 10. Okay, in this one we have a rhombus with the perimeter is 164. So I took 164 and divided it by 4, and that's how I got each of these side lengths are 41. Then the diagonals are perpendicular because it's a rhombus, and they also bisect each other because it's a parallelogram. So in orange I divided that into two 9 length segments of length 9 units. So the other diagonal has to be 80 because this creates a right triangle. And if you do the Pythagorean theorem, do like 9 squared plus x squared is 41 squared, you get that this other part is 40. So if you have that whole diagonal, you get 80 over the other whole diagonal is 18. Multiply them together, divide by 2, and you get 720. Okay, in this last one we have to find the area of a square that's inscribed in a circle. So it's drawn right there, where r is the radius. So if we think of r as the radius here, and we draw the other part, it's going to create a diagonal. So that half of the diagonals are, that half of the diagonals are. So this creates a right triangle here where the legs are r. So this side length is going to be r root 2. So if you square the side length to get the area of the square, you get r squared times 2, or just 2r squared. So that would be the area of the square inscribed in the circle in terms of the radius. You just square the radius and double it.